Welcome to today's class, and we'll be working on derivatives of exponential function. So when you hear the word derivative, we still mean the differentiation when we have an exponential function. Now, what do you mean by an exponential function? It means function that is of f of x equal to exponential of x. So when we have this e means exponential. Is that written this way or is written this way? Exponential of x. So you can see it's written either on this way. So if you have a f of x equal to exponential of x, and they ask you to find the dy dx of that. So let's say we are taking the f prime of x, which is like saying the dy dx, your dy dx of your exponential of x is actually going to be giving us what? Still exponential of x. So we're not doing the proving, but this is just the explanation. So this will still give us what? The exponential of x. So if you have to differentiate just the exponential of x, you still get the exponential of x. But take for instance, if we were to differentiate the exponential of x plus 1, what will it be? For our y is equal to exponential x plus 1. Then our dy, the x, will be equal to what? In this particular case, you still solve this like as if you're solving a normal value where you have to bring your this value here, you bring it to the down to the base side, right? You take it from the power down to the base. Now that's what you will do here also. You take this particular one and you take it to the base. It's like doing what we call a chain rule. So this will look like a chain rule. Now let me explain what's going to go on here. In this part, you say let me wipe here off. You say let u be equal to x plus 1, and then let your v be equal to your exponential raised power u. Now we already know that, therefore we know that we're working with what? For the dy dx, for dy dx, it will be equal to what? To be equal to du dv, that's du dx multiplying dv du. Is that okay? So what will it be? Our du dx, that's u with respect to x, will be what? For our u with respect to x, we have that differentiating this, what do we get? We get what? 1, because when you differentiate du, when you differentiate du dx, here becomes 0, our 1 becomes 0 because it's a constant, while our x, differentiating our x, will give us what? 1. So here it gives us what? 1. So we write it out, 1 multiplying our dv du. So for our dv du, remember differentiation of an exponential function still gives you back that exponential function, right? Like exponential of x will give you what? Exponential of x, and exponential of u will give you exponential of u. So that will be what? Exponential u. So this is 1 multiplying exponential u. This dot sign means multiplication in mass. So this is equal to what? Exponential u. But what's our u? Our u is what? X plus 1, and we are done. So differentiate this still gives us the same value. Now let's take another question. Let's say if we're asked to solve this one, if we're asked to solve exponential of 2x plus 3. So if our y is equal to exponential 2x plus 3. Now what do we do here again? In this case, we say let our u, let u be equal to what? Our u be equal to 2x plus 3, and our v will be equal to what? Exponential u. So our du dx is equal to what? Just 2, right? And our dv with respect to u, because our v with respect to u will be what? Will be still exponential u, since doing this will still give it the same thing. Now our dy dx will be equal to what? Dv du multiplying du dx. Now that means what? That means 2 is multiplying what? Exponential u. And what's the final answer? To be 2 times 2 multiplying exponential. What's our u? 2x plus 3. So this is the answer here. 2 exponential 2x plus 3. Now let's take another question again. What if we're given exponential of minus x squared? Exponential, that's our y is equal to exponential of minus x raised power 2 again. The same thing applies here again. So what happens? Our u will be equal to what? Minus x raised power 2. Our v will be equal to what? Exponential u. And then what happens again? Du with respect to the x will be equal to what? Minus 2x. I believe you know how to do that. You add the minus, this will be a minus 1, and then you take your 2 over to this way, so it will be minus 2. When you say 2 minus 1, it's going to give us 1, so that's why we have minus 2x. Okay, so that's just to remind us on how to differentiate. Now what again happens here? Then for our dv dx, that'll be what? Still exponential u. So exponential u. So therefore our dy dx is equal to what? Dv du. Sorry, this is meant to be du, since it's with respect to d, is with respect to u, because it is with respect to what? U. So dv du multiplying what? Du dx, and that is what? Minus 2x multiplying exponential u. What's our exponential u? Is minus 2x. Exponential u is what? Exponential minus x raised to power 2, right? So this is the final answer. Minus 2x exponential minus x squared. Now that's how you solve questions like this. Now let's take some more interesting ones here. What if we're given to solve this? Let's take our screen down. What if we're given to solve this particular question? Let's take this off. If we're given to solve this one, 2 exponential of x plus exponential minus 3x. Now solving this one, this is for y is equal to this. Now therefore for our dy dx to be equal to what? Now differentiating this one will just give us what? It will give us 2 exponential x still. I'm sure you know that already, because there's whatever value, if you have to differentiate this up 1 and bring it down here, it will still give us 1, and 2 exponential x will still give us 2 exponential x when you differentiate it. So adding it plus what? Differentiate this one, it just means take your minus, because if you differentiate this one, bring it down. I believe we don't start solving we don't touch on the differentiation again, but just for ease sake, I will show you the differentiation for this particular case so that we will just go through it together. Now it means that our u, let's do it for each of them. So let's do for the first one, for 2 exponential x, let's differentiate this one. We know that our u is equal to what? Our u is equal to, let's say, is equal to x here is equal to x, and our v is equal to what? 2 exponential u, right? Therefore our du dx will be equal to what? 1, and our dv du will be equal to what? When you differentiate this one, you still be having what? 2 exponential u, right? Therefore our dy dx is actually multiplying this and this, and what do you have? You have 2 exponential u. But what's our u? Our u is what? X. So 2 exponential x. That's how we got 2 exponential x when we are, if we are to find the dy dx. Then let's use for the next one, 4 exponential minus 3x. We have that our u, let our u be equal to what? Minus 3x. Our v be equal to what? Be equal to exponential u. So our du dx will be equal to what? Minus 3, and our dv du will be equal to what? Exponential u still. Therefore we know that dy dx will be equal to what? Multiplying these two together, what do we have? Minus 3 exponential, what's our u? Our u is minus 3x, right? Minus 3x. So we can answer that, hence our final value will be that dy dx. So let's call this one dy dx1, dx2, just put the subscripts together, and this one is 1, dy dx1. So dy dx finally will be adding these two together, and that will be what? 2 exponential x, and then when you add this one, it is minus what? 3 exponential minus 3x. So this is the final answer. Now let's take some more questions to do. Let's take some more tough questions. X squared, what about this one? Let's try this one out. We have this question on the board. When your y is equal to x squared exponential of minus x. Now solving this case, we're going to do the same thing again. Our u, so our u will be what? Our u will be the values for x. So we have our u, this part here. Now notice something, this is actually a product case, right? Because we have one function multiplying another function, right? So since that happens, since we're having this kind of case where two functions are multiplying each other, let our u be one of the functions. So our u can be what? X squared. And then if our u is x squared, our v here will be what? Exponential of minus x. So now we have to now solve it. Remember, what is our formula for product rule? Our formula for product rule is that dy dx is equal to what? Remember it? V du dx plus what? U dv dx. That's why you must be very familiar with all these rules so you can easily tell when to apply it. Notice we are applying this product rule because we are seeing two functions of x multiplying each other and they are different. This is x squared multiplying exponential of minus x. Therefore, in this case, for our u, we have to differentiate it. So differentiating our u, what will our u give us when we differentiate it? So we have that du dx will give us what? 2x, right? And then for our dv du, we know it's going to give us what? This minus will come down here, making it what? Minus exponential minus x, right? So we can then solve it finally. For our v du dx will give us what value? Our v is exponential minus x multiplying our du dx, that's 2x, plus our v, our u dv, u is what? X squared, and then our dv dx is what? Minus exponential minus x. So therefore we can multiply the two of them to give us what? 2x exponential minus x. Then this plus will actually change to minus because minus is multiplying plus here. So therefore here will be minus x squared exponential minus x, and this is your answer for what? Dy dx. Okay, so let's take one last solving just to drum it in. One last solving, one last equation again. So we have this for your y equal to exponential 2x over x. Now this is a quotient form, right? Because we are saying one function of x dividing another function of x. So again, what do? You bring it out. You let your u be equal to what? Exponential 2x, and then your v is equal to what? X, right? So what's your du dx? That will be what? Our du dx will be 2 exponential 2x. I believe you know that by now. You just take this value down and you differentiate the value when it comes down. So it will be 2 exponential 2x. And then for your dv dx, we know the value will be equal to what? 1. Now, therefore, we can now say that our dy dx, remember what's the formula for your quotient? It is u dv dx minus v du dx all over v square, right? So using that to solve, we have, let's not go to, we have that our function will become what? For our derivative, our u is what? Exponential 2x multiplying our dv dx. What's our dv? This is our dv dx. Dv dx is what? 1. So multiplying 1 minus v, our v is what? X, multiplying du dx. What's our du dx? That is 2 exponential 2x all over our v square is what? X square. So solving this, let's move on to the other side. Let's solve this. So solving this, we have that our dy dx is equal to exponential 2x multiplying 1 will still give us what? Exponential 2x minus, here is 2x, so that will be 2x actually. 2, because x multiplying 2 give us 2x exponential 2x all over x squared. And we can factorize this. Since we're having exponential 2x and exponential 2x here, we can factor them out as what? Exponential 2x brackets 1 minus 2 exponent 2, okay, 2x, 1 minus 2x, since we factored out exponential 2x over x squared. And that's the answer, so you can stop here. So I think I would like to stop here, or should I take one last question? I'm tempted to take one last question. Okay, let me just take this last question and then I'll call it a day for this particular work we've been doing. So one last question. So we have this one. If we have our y to be equal to bracket exponential x minus 1 raised to the power of 3. Okay, so again, this is a chain rule, right? This is a chain rule because you're having a function inside another function. So let's break it down. So we know that our u will be equal to what? Let our u be equal to the one in the bracket exponential x minus 1, and let our v be equal to our u, which is this, raised to the power of what? 3, because that's how it looks like here, right? So therefore, our du dx will be equal to what? If you differentiate this entirely, remember differentiating exponential x will still give us exponential x. Differentiating minus 1 will give us 0, right? Because when you differentiate the constant, you have what? 0. So this is entirely out. So what you have is just exponential x. Then the v, the x, this is actually v. My v looks like a y. So let me put that again. The v dx is equal to, this will be what? Sorry, dv dv du, because this is now with respect to what? U. So it is dv du. This is with respect to u. So our 3 comes here, and we have minus 1 here. That will give us 2. So it will give us what? 3u raised to power what? 2. So when we now solve it, remember our formula for chain rule. It is dy dx is equal to what? Is equal to, for chain rule we have this, that's the two functions. That will be du dx multiplying dv du. So what do we have? Our du dx was what? Exponential x multiplying our dv du, that's 3u raised to power 2. So solving it, we have 3 exponential x, and our u is what? Our u is exponential x minus 1. So it is bracket exponential x minus 1 raised to the power of what? 2. And that's it. So thank you. The next one we'll be taking is actually it will be derivative of logarithmic functions. So see you in the next class.